All right, so this assignment is chapter 2.1. Okay? Chapter 2.1. So it's going to look like this. MTS ALG2 homework or HW 2.1. Right? Question. And I skipped 17 and 19 just because I'm not going to make you do the tables. I'm cool with that. Okay? What I really want you to do is understand the math. Okay? So instead of doing the tables, let's just get going on the math. 21 through 31. Okay? And let's just see how we can do this. So, what we're trying to do is describe the function, right? And describe the transformation that's going on here. Okay? Is this inside the box? Right? Is it inside the box? And a lot of people think it is inside the box. But it's not. Remember, the function, what is the parent function? The parent function is f of x equals x squared. Yes? Okay? So, if the parent function is f of x equals x squared, sorry about that, that looks really sloppy, so I want to, equals x squared, right? That means this is outside of the box. If it's outside of the box, then is that vertical or is that horizontal shift? Vertical. Very good. It's f of x minus 2. If it's vertical, minus 2 means down 2, right? That was easy. Was that easy? Okay. Oh, that's 20. We didn't have to do 20. All right. So let's do 21. Same thing. Is it inside the box or outside the box? It's inside. Notice it's inside squared. Right? So is this thing on? Good, good. Okay? So if it's inside the box, then that's a horizontal. Right? And x's do the opposite, yeah? So x's do the opposite.
So it's x minus left.
So it's x. It's actually x left. Right? So this is saying plus, and it's opposite of plus, so it would be right. Or left. Sorry. Left. So here you're saying x's do the opposite, right? Of plus 5. Plus 5 means right. What's the opposite of right 5? Left. So x opposite of right 5. And so we say opposite of right means x left 5. So it's a horizontal. Left means or, right? Horizontal. Okay? So it's horizontal shift. Right? Horizontal shift left 5. Okay? So we look at what question? Let's try it again. So x opposite would be x left 5, and then let's change the color real quick. So that means I got a horizontal shift left 5. Because x's are horizontal, right? Horizontal shift left 5. And then if I went from here, I could go back to x plus 5. See how it goes back and forth? We got to be able to go back and forth. Notice how we did that last semester, or last test. Okay? We were going this way. They said, oh, you got a horizontal shift, left 5. And then you were like, oh, left means minus, and horizontal means x opposite, and opposite of minus is plus, and so I come up with x plus 5. So you got to be able to go backwards and forwards with it. 23. Again, x is the opposite, so opposite of right is left. Left 4, and then the whole shift is how much? Down 3. It's that simple. Left 4, down 3. Done. Keep it simple. Okay? X's do the opposite. Opposite of right is left. Because a plus is right. Is that right? But we do the opposite against the X. Opposite of right is left. So left 4, down 3. Sorry, that's kind of cutting off the... Does that make sense? Left 4, down 3. Okay? 25. What are we doing here? It says left 4, but it's the opposite. It's X. What's the opposite of left 4? Right 4. So it's right 4, and then what is this? This tells me that it's up or down? Down. How much? 9. It's that simple. Guys, I can't make this easier. I can't make it easier. This is, if you're paying attention, right, Tyler? If you're paying attention, this can be easy. You've got to be paying attention. I can guarantee you I can make this, you understand this. I can't make you understand it if we're not listening or paying attention. Okay, 27. Right? 27. Is that inside the box or outside the box? Outside. Right? So, this is the hard one. This is the one that says, oh, it's negative. So it's an X reflection, right? It's an X-axis reflection. Okay? And is this since it's outside the box, is it vertical or horizontal? Vertical. Vertical what? Stretch. Why stretch? Because it's bigger than 1, right? If it were less than 1, and look, they're at. Oh, this makes me upset. Because right here, this is exactly what I'm talking about. They don't teach it in the book, but then they expect you to know it. But because I've taught you before, what does this mean? It's inside the box, right? It's inside the box. What does that inside the box mean? Horizontal. Horizontals, X's do the opposite, yeah? What's opposite of compression? What's opposite of compression? 3/1, right? Or stretch of what? So it's a horizontal stretch of how much? 3, or 3/1, right? So they didn't even teach this. How do you get that from this? Where does it tell you that it's a horizontal? Where? This came straight from the freaking book, right? They don't even. That's what frustrates me. Because it frustrates my students. You know? You're like, why are the problems harder than what they teach you in the book? Constantly. That's why I don't even really teach from the book. I look at the problems and I teach what you got to be able to do. Okay? So here, easy. It's outside the box. So it's vertical. Yeah? Okay? Vertical means it does exactly what we want it to do. In this case, it's a reflection because the negative is that frowning one, right? So instead of smiling, it's frowning, and it reflects on the x-axis. So that's good to know. Okay? And then, because this is bigger than 1, we know it's a stretch. Stretch, how much? Well, 20. What kind of stretch? Vertical, right? Vertical stretch 20. So it's an x-axis reflection with a vertical stretch. Meaning it'll get tighter, right? So instead of this function being like this, it's going to flip, right? So it's going to be like this, and then it's going to get tighter. It's going to look like that. So it's going to flip on the x-axis, and then it's going to look like this, real tight. This is being pulled. It's being pulled like that. vertical stretch. I'm grabbing it with two ends and vertically stretching it. Okay? Like Cedar asked me to do for her the other day, so she could be taller. Just kidding. But see, if she got taller, she would get skinnier. I don't know if she wants that. We wouldn't see her anymore. Okay? Alright. Parent function on 29. Parent function of f of x. So can I erase some of this stuff so we can read it? Okay? So at home, you can just pause it, rewind it, whatever. So I'm just going to use the eraser. And I'm going to make it big so I can get rid of all this stuff right here. Okay? Good. Alright. Go back to pencil. Alright. So I've got the parent function of f of x is this. X squared. Yeah? Okay. It's reflected across the x-axis. So that means it's negative. Right? So we know that the first part's negative. Okay? The vertical compression, that means it's multiplied outside the box, right? Of 1/2. And is translated to the right, which means plus, but because it's translated right, it's an x opposite of plus, which means x minus, to create g, translated 1, okay? So it's x minus 1, okay? So we know it's x minus 1 squared. So I got g of x, right? And let's put this in black. G of x is equal to x minus 1 squared, right? Because that's what we're doing here. Going right means I do the opposite, so it's minus 1. Okay? And then the factor is vertically compressed. That means it's, let's change that picture. So this vertically compressed means that I have a 1/2, right? So we don't flip it because it's vertical, right? We do exactly what it says to do. Okay? But it's outside the box. Yeah? But it gave us this reflected across the x-axis. What does that mean? Do you remember? That means it's negative, right? So we just go, okay, negative 1/2. There it is. Negative 1/2 times x minus 1 squared. Bam, there's g. Okay? Easy? Alright? Alright, then 31. Oh, I don't think I had to do 31. We're just going to 29. And that's it. That's homework assignment.